The lecture today is going to finish up Chapter 3. We're going to look at the separation of mixtures, and we're going to reinforce this concept in the lab as well. So, separation of mixtures. Mixtures can be separated based on different physical properties of the components. So we can look at differences in boiling points, and we can use a technique called distillation. We can look at the differences in the state of matter, solids, liquid, and gases, and we can use filtration. You know how to do filtration already. If you've ever strained spaghetti through a strainer and you've separated the solid spaghetti from the liquid water, that's filtration. Adherence to a surface, which is called chromatography, and we'll discuss that a little bit, and volatility, which is evaporation. So this is a setup for distillation. We're not going to do a distillation in our classroom as far as setting it up to condense it and preserve the water and the salt in this manner, but you will separate water and salts, but not use a closed system to do it. So in this case, what we have is salt water, and we know that the boiling point of salt and the boiling point of water are two separate amounts, and we use the burner to boil off the water. So the water is boiling. Once it reaches 100 degrees, it's just H2O, there's no sand left in it, and it's going to go back down this tube, and it's going to condense, and it's going to turn back into liquid water. And the liquid water is then collected again. So you have pure water here, and eventually, once all the water has been boiled away, you have salt in its original form left behind. So during separation of mixtures, there is no chemical change between it. We have the saltwater solution that we had when we physically separate it using heat and using distillation process. We have salt left behind and we have pure water left behind, which were the mixture together when they were in the saltwater solution, which was a homogeneous mixture. Let's look at filtration. Filtration, like I said before, if you have ever strained spaghetti, you have used filtration. This is a mixture of solid and liquid, and we know that if we could trap the solid and the liquid run through, we could separate the two. So we're going to use this in the lab as well, and you're going to have a setup identical to this setup. You're going to use filter paper to use instead of like the colander for the spaghetti. This is filter paper that's going to be allow the water to go through and hold back the particles that you're trying to catch. This is the funnel, and we're going to collect the liquid down here at the bottom. This is just the final slide for the entire chapter, and like I said, it's been a very quick chapter and a lot of common knowledge things have been in it, but we need just to make sure that we know exactly what we're talking about when we look at the organization of matter. This flow chart is in your textbook, and it does a great job showing you how all the different things of matter that we were talking about are connected. For example, matter can be broken down into heterogeneous and homogeneous mixtures. And we can use physical methods to separate the hetero and the homogeneous mixtures down to a pure substance. Those pure substances are either going to be compounds or elements, and we can take the compounds and further break those down using chemical methods into the individual elements. Matter can also just be a pure substance. That pure substance, again, is either made up of elements or compounds, or maybe both. But if it's made up of compounds, I can then take chemical methods to break down the compounds and change it back into elements. So while matter is anything that has mass and takes up space, there are different forms of matter that we need to be aware of, and we need to be able to recognize what type is what when we're in the lab, and also when we look at our test in the next couple of days after we finish and complete the lab. That's going to help us better understand the organization of matter.